Okay, problem 5.3, calculate the following limits. So we keep on doing limits. Okay, in this case we have 9 of them. Okay, so we have the limit. The difference here is that the limits are when x goes to infinity or minus infinity in some cases, right? So I have the limit when x goes to infinity of x cubed plus 4x, minus 7 divided by 7x squared minus the square root of 2x cubed plus x5, right? Now here's what we need to use our asymptotic equivalences. The numerator, right, is asymptotic equivalent to x cubed when x goes to infinity, right? In the denominator we have that this thing, the square root of 2x to the 6 plus x5 is asymptotically equivalent to the greater term, which is 2x to the 6, but the square root of that is the square root of 2x cubed when x is going to infinity. But we're summing 7x x squared, right? But x squared is negligible, right? 7x squared is negligible with comparison with the square root of x cubed, right? When x goes to infinity again, right? So we can substitute the numerator and denominator with this, the numerator with x cubed and the denominator with the highest greatest degree term, and there's a minus here, so minus 2 square root of 2x cubed. X cubed and x cubed cancel out, and then you have minus 1 over the square root of 2, or if you want, minus the square root of 2 over 2. Okay? Now let's do part 2. The limit when x goes to infinity of x plus the sine of x cubed divided by 5x plus 6. Now, the sine of x cubed is bounded, right, between 1 and minus 1. So that means that this is negligible with respect to x when x goes to infinity. So the denominator, the numerator is equivalent to x, and in the denominator we have 5x, right? Because 6 is negligible in comparison with 5x when x is very large. So then we have a fifth. Okay? Now let's do the limit when x goes to infinity of the square root of x divided by the square root of x plus the square root of x. Sorry, wait a minute. How to say this? This is the square root of x plus the square root of x plus the square root of x. Okay, which is kind of crazy to say. But again, x plus the square root of x is asymptotically equivalent to x. Okay, and so then we have here x plus the square root of x. But x plus the square root of x, sorry, this is when x is going to infinity. But then here again you can apply the same argument. So this x plus the square root of x is asymptotically equivalent to x. So then you have the limit when x goes to infinity of the square root of x divided by the square root of x, which is 1. Okay? 4. The limit when x goes to infinity of the square root of x squared plus 4x minus x. Now we do, as we always do, multiply by the conjugate and divide. So we have the limit divided by x squared plus 4x plus x, and then we have x squared plus 4x minus x squared in the numerator. X squared and x squared cancel out, and then this is asymptotically equivalent to x, right? So then you have the limit when x goes to infinity of 4x divided by 2x, or in other words, 2. Okay? Let's do part 5. Okay, so these are interesting because we now have 2 limits, right? This is this says the limit when x goes to plus and minus infinity, but this doesn't have to be the same limit, right? So this is the limit when x goes to plus infinity. Let me rewrite this. The limit when x goes to plus infinity of e to the x divided by e to the x minus 1, and the limit when x goes to minus infinity of e to the x divided by e to the x minus 1. Okay? Now, when x goes to infinity, we know that e to the x is monotonic increasing, it grows, so this is asymptotically equivalent to e to the x minus 1 is asymptotically equivalent to e to the x when x is very large. Okay, so then we have e to the x in the numerator, e to the x in the denominator, we have 1. Okay, now when x goes to minus infinity, this goes to 0, right? We know this is e to the x. When x goes to minus infinity, this is getting smaller and smaller and smaller, right? So this is something that goes to 0 divided by minus 1, because this is asymptotically negligible when compared to this. So this is 0. Okay, so this function has two different behaviors when it goes to plus infinity and minus infinity. Okay? Okay, let's go to part 6. Part 6, this is the limit when x goes to plus infinity of x minus 2 divided by the square root of 4x squared plus 1, and then the limit when x goes to minus infinity of x minus 2 divided by the square root of 4x squared plus 1, right? Now, when x goes to plus infinity, right, this is the square root of 4x squared plus 1 is this gets very large, so this is negligible, so then you have this is asymptotically equivalent to the largest term, but this is asymptotically equivalent to 2x, right? So this limit is the limit when x goes to plus infinity of x minus 2 divided by 2x, or in other words 1/2, right? Now in this case, what we have is the limit when x goes to minus infinity. This is also asymptotically equivalent to 2x, but now what we have is the absolute value, if you want, right? So maybe it's easier if we write when let's call it y is equal to minus x, right? So what I want to say by this is that x is going to be to minus infinity, but the square root of this is going to go to plus infinity. Okay, so we can call it the absolute value, okay, of 2x, right? But x is gone. Let's do it. Maybe it's easier like this. Okay, this is the absolute value of x. So the limit when x goes to minus infinity of x minus 2 divided by the absolute value of 2x, right? Normally we don't care about this because we're always thinking about positive numbers, but in this case, when x is negative, right, this is going to be positive, right? And so this is going to be minus 2x when x is very negative. So this is the limit when x is going to minus infinity is going to be x minus 2 divided by minus 2x, or in other words, this is minus 1/2. Okay. Another way of thinking about it is to say, think about this variable y, which is minus x, and then so we have the limit when y goes to plus infinity of minus y minus 2, right, of 4y squared plus 1. Okay, and then we have it again when y goes to plus infinity, we will have minus 1 divided by 2y, so this is 1 minus 1/2. Okay, so both ways of thinking about it work. Okay, let's do part 7. So 7 is the limit when x goes to plus infinity of the hyperbolic tangent of x, and then the limit when the x goes to minus infinity of the hyperbolic tangent of x, right? Now, the hyperbolic tangent, if you remember, is the quotient between the sine and the cosine, hyperbolic sine and hyperbolic cosine. So you have e to the x minus e to the minus x divided by e to the x plus e to the minus x. Now when x is very large, right, e to the minus x is negligible in comparison with e to the x when x is going to plus infinity. So this is equal to the limit when x goes to plus infinity of e to the x divided by e to the x, or in other words is 1. Now when x goes to minus infinity, this is the other way around, right? So x, e to the x is very small, and e to the minus x is going to infinity when x goes to minus infinity, right? So the limit when x goes to minus infinity is minus e to the minus x divided by e to the minus x, which is minus 1. Okay? So actually the hyperbolic tangent has two horizontal asymptotes. We'll see that in the next unit, and it does something like this. Okay? It's easy to prove that the function is injective. It's odd also. Well, okay. Let's do part 8. So this is again the limit when x goes to plus infinity of e to the x divided by the hyperbolic sign, but let me write it like this. The hyperbolic sign, as we have just seen, this is e to the x minus e to the minus x over 2, so this is 2 times e to the x divided by e to the x minus e to the minus x. And the limit when x goes to minus infinity of 2 times e to the x divided by e to the x minus e to the minus x. Now, when x goes to plus infinity, this thing is important and this not, so then you have 2. And when x goes to minus infinity, this is the one that matters, so you have 2 e to the x divided by this, but this is going to minus infinity and this is going to 0, right? E to the x when x is going to minus infinity is going to 0, so you have 0. Okay? Now, let's see, we have the last part, the limit when x goes to plus infinity of 2x plus 7 divided by 2x minus 6 to the 4x squared plus x minus 3, and then the limit when x goes to plus infinity of 2x plus 7, sorry, this is minus infinity, 2x minus 6 to the 4x squared plus x minus 3, right? Now again, this is going to be one of those 1 to the infinity limits, right? The limit of this is going to 1. It doesn't matter if this is plus or minus infinity, and then this is going to plus infinity, right? Because this is asymptotically equivalent to 2x, right? So now this is e to the c, right? Let's call it c1, and this is going to be e to the c2, right? c1 is the limit when x goes to plus infinity of, and then we have 2x plus 7 divided by 2x minus 6 minus 1 times the square root of this, right? Now this is going to be, let's see, the limit of 2x plus 7 minus 2x plus 6, right? Divided by 2x minus 6, and this is asymptotically equivalent, as I said, to 2x, right? In this, so this is asymptotically equivalent, it doesn't matter, to the absolute value of 2x, okay? This is important for later. So then we have 2x here, 2x cancel out, you have 13, right, times 2, 26 times x divided by 2x, so you have 26 over 2, or in other words 13, right? So this is e to the 13. And similarly we can do c2, which is the limit when this goes to c2 when this goes to minus infinity, right? This thing is the same, this thing is the same, but when the limit when this is going to minus infinity is minus x, right? Because this is the absolute value of 2x, but when this is negative, this is going to be 2x. So this is going to be minus 36 minus 13. So this is e to the minus 13. Okay? Or if you want, you can do the same trick as before. You think about y is equal to minus x, and so the limit when x goes to minus infinity is the same as the limit when y goes to plus infinity. And then you substitute here and you will get the same result. Okay? And that is the end of this exercise.